question to Dennis. You say you're getting carbonate from chloride. That's a fairly hard ask to get. You've got the MGFE. What do you do with the alumina? And in a lot of mines in Western Australia, we've noticed that you get the amphiboles going to anchorite and quartz, and you get the chloride going through a hydrothermal illite to sericite through to sulfidation. Can you comment on that?
Sure, yeah. Well, the host rocks are predominantly different in central Victoria, so we're dealing, at least in the examples I was talking about, exclusively sedimentary rocks. The interpretation that the carbonates are replacing chlorides comes from the seemingly mutually exclusive relationship between the two. And I think the aluminium and the silica, depending on what the potassium to hydrogen activity ratio is, could be going into white micas, or it could be even going into kaolinite.
Question for John. You were telling us that the SEM approach is too expensive, which I agree. What about doing a whole lot, multi-element geochemistry and converting that to mineralogy?
Well, it's a
sophisticated program.
It's a black art. There are people like Halley that are exquisite practitioners of the black art, but it is a black art. And one of the problems, I ran across it just very recently with one of your PhD graduates, like the last couple of days, he remained nameless. It looks to me like he copied the Iogas template, whereas there needed to be some thought going behind it. So I've observed this a couple of times in recent years, that people are just using the template and not. So that's what I mean about the black art, that there's a non-unique solution with trying to invert the whole rock data into mineralogy. It's just a lot better to measure the mineralogy. That's at one point. Another point is that a lot of those critical mineral distributions we're worrying about, they're just trace level. Barth and I are astonished at the systematic patterns you get with sub 1%, sub 0.1% magnetite or an iron oxide, pyrite, pyrrhotite, sulfate. Well, I'm astonished about the very low levels of sulfate in places in these gold systems, and it maps out a pattern. So it's kind of, and it makes, you can see texturally looking at those images that it's in the paragenesis. So there's a wealth of information in this kind of approach that is much richer. It will allow us to actually, for me, it will allow us to actually go out and map the chemistry. So we'll end up with redox maps, pH maps, temperature maps, real maps of the systems. And I'm driving a kind of my thing is, which I'll probably never see, my thing is that the surveys and GA, all those institutions, won't be putting out mineral maps, they'll be putting out mineral system chemistry maps. And if they ever get around to doing this, they'll have an extraordinary impact. So that's got to be the goal. They're the big ambitious goals, and we need this technology. But it is true that the SEM work as it is now is actually too slow, too expensive. But you just look at the LIBS technology and all these other things that we talked about today, and it is possible to take the next step. I'm absolutely convinced that it is possible that you get these kind of technologies in play at a cost and a time frame that would fit into an exploration workflow. Now, how much they will disrupt the other technologies, who knows, but I think it could be done. Here endeth my little pitch.
But I think you're underestimating how far we've gone now with converting whole rock geochemistry into mineralogy. It's just about there. But I agree, it's not going to find minerals that are less than 1%.
No, I remain sceptical on that point. I take the point there's some really good practitioners, but I think there are non-unique solutions, And one of my beefs about the geochemistry community is they never talk about non-unique solutions. The geophysicist is much better at fronting up and saying, you know, I could have X, Y, Z interpretation of my data set. The geochemists, you know, they don't do that, they should.
I have a question, John. If there was, say, I don't know, a 5,000 hole sample, bottom of a hole air core, and you did 200 or 100 SEM to, and you can do this with spectral mineralogy, so many other things. It is all about augmenting, but how much bang for the buck for a company that's got that large data set if they did 200, or do they need to, the maps that you make need an SEM point at every point?
No, we're, Bath and I are just hopeless, so we just oversample all the time because we're academics. But actually the point is well taken. You could collect much less of this data and relate it back to the other data sets, so that's, you know, that is one way forward.
Just a question to everybody here. Whatever happened to stratigraphy? We seem to have gone aerial. Where is stratigraphy?
I think we should put Carl forward because that was one of the areas he left off his talk. Number one, I believe.
It's number one, yeah. Immobile element geochemistry, and I include all the rare earths. You can revolutionise the stratigraphy of just about any project, I would say. It's, to me, one of the most underutilised of the disciplines. Because we're dealing with altered rocks, we can't use our major elements to classify rocks very far. But the trace element, immobile element signature, yeah, I've got some examples of that which are really, including panorama. That went through several stages of the white rocks are felsic, the dark rocks are mafic. No, somebody saw some white pillows. It's all basalt. And then Noel White came and said, do you know what leucoxene is? And we were introduced to titanium-zirconium ratios. And this all happened before I arrived, which was just as well because you can't launch a decent alteration study till you understand the rock types. But in the 65 element data, the extended trace element patterns of the volcanics are almost identical for a basal and an upper suite. So they're derived from almost exactly the same source. But on a thorium-zirconium plot, they're like that. Just two completely separate lineages. And when you map that out, it's an upper and a lower sequence. There is no massive sulfide being found on this newly recognised contact, but you would never have mapped it. You never would have mapped it at all. In another VMS system, a subtle difference like that would find you a new ore horizon.
In the Kalgoorlie area, in the whole building, what we're looking at there, we've got the two mineralisation types. We've got the cross-cutting in the diorite/grey-whack beds, the tangential. Then we've got the lode zones and the shaly zones, or the shears. And Victoria's now getting very important with the sulfidic shales. So Victoria's only got about 40% of its gold found so far in shales. But, you know, especially the work at Kundana, the bedding down that, and even that slide you showed on the face, the bedding, everybody seems to be not looking at the bedding and saying, hey, we can tune our exploration by looking at stratigraphy.
Can I just make the comment in support of what Carl just said? Is the multi-element data sets and the 4-acid digest and even the portable XRF data sets actually give you a lot of information about the immobile elements. So as part of our workflow, we are looking at the stratigraphy, putting it redoing it basically, so that we're looking for a very robust architecture that we can look at the alteration in a geological context, because we're trying to sort out the pathways of the fluids. And you're never going to do that unless you've got your geology sorted. And I agree with Carl. I mean, these multi-element data sets allow you to pull out these sequences that haven't been seen before and start subdividing the white flag or the black flags into units that haven't been done before. And it does change the picture. I was having a discussion just yesterday afternoon about how much we're going to disturb the clients. How much we're going to redraw their geology for them, and you know, because we'd got on to a particular, it came out of the multi-elements and the immobile elements. Very simple. I've forgotten what it is. It's just like niobium or something. Just one bit of the white flag beds had more of that, and it was a consistent pattern. And I mean, it looks to me like we might end up changing some architecture. So that is not forgotten about, and it's a really important part of the business of constructing the mineral system. Just that today was, you know, we were just celebrating alteration. Well, I was.
I might just add on just on the sedimentary rocks, because I was talking about your classic volcanics where people think of immobile elements, but sedimentary rocks are just broken down chunks of igneous, and you're mapping different provenance. And so the immobile elements in sedimentary sequences, I reckon, is barely scratched the surface to improving our understanding of stratigraphy.
Okay, any more questions? Good. In that case, I'd like you to thank the speakers for session 4. Thank you.